Welcome to my projectbazaar.com.
Now we discuss about the product for hardware implementation of an OFDM transceiver for 802.11n systems. Next we see the abstract for the product. Orthogonal frequency division multiplexing is a multi-carrier based on technique for mitigating ISI to improve the capacity in wireless systems with spectral efficiency. Multiple input, multiple output system have achieved attention as it is promises to increase the capacity and performance with acceptable BER probability with the number of antennas. The combination of MIMO FDM is the beneficiary. The MIMO FDM system comprises of transmitter and receiver section. This transmitter comprises blocks such as conventional encoder, mapper, parser, and IFFT. The data encoded at the specific rate like 1 by 2 or 2 by 3 are then in the modulated using the various modulation scheme such as BBSK, QBSK, QAM. The signal is then passed into the two or more channel and later it's converted into time domain and the transmitter. This operation receives the blocks or opposite to that the transmitter and receiver actual signal. The paper is organized in the order of mentioned as follows by the describes the about MIMO and MIMO based technique like STBC and SM. These forecast for MIMO system using the MATLAB Simulink and Xilinx software for our architecture designs development. The MIMO system multiple antenna are employed as the transmitter and the receiver. MIMO transmit and receiver two or more data streams through the signal radio channel. Thereby the system can driver two or more times the data rate as per the channel without additional bandwidth or the transmit power. The addition of multiple antenna and the transmitter combined with advanced digital signal processing based algorithms and the receiver held a significant advantage in terms of capacity and diversity. Space-time block coding and spatial multiplexing are MIMO based technique that provides like quality and high capacity in this system. STBC and SM can be combined with give a transmission gain that will maximize the average data rate with the MIMO channel and graduate the minimum order diversity benefit for each stream process. The best approach for real-time application to achieving the high throughput and the network capacity for fourth generation wireless local area networks is to combine with MIMO wireless technology with OFDM. This paper focuses a high-level MATLAB Simulink forecast for spatial multiplexed MIMO OFDM transceiver encoder and the 1 by 2 rate of using the 64 size FFT are designed to implement the MIMO OFDM architecture and to convert the VHL code and to calculate this synthesis report for MIMO OFDM process. Next we see the flow diagram for the product. The 5G input data bits signals to combined with the parallel to serial converting process and to add the addition process. This parallel to serial conversion process to convert the data into signal analog to digital conversions, then to apply the parallel forms to serial positions and to add the two type of signal, then to calculate the signal mapping positions. The mapper is converted to mapping the signal based on our hierarchical based design formation for MIMO parser architecture Simulink designs. These Simulink designs mainly to convert the cyclic prefix removal designs oriented calculations and to apply the FFT based process. This FFT based process is like a addition work for our MIMO transmitting signal for MIMO OFDM process, then to apply the receiving section IFT process to addition work, because FFT process consists the addition multiplication process, but we develop only for addition work to do the FFT complexity reduced process, then to apply the inverse position and to remove the cyclic removal prefix positions level and to apply the deparser architecture. This deparser architecture to design the demapping for overall hierarchical based designs to apply the signal demodulation process, then to calculate the signal decoding results, thus to decode the data for transmitter and receiver sections. These two serial to parallel conversion to apply the data output results. Then we calculate the transmitter bit rate calculation and to receiver bit rate calculation. Because the MIMO used to calculate the reduce the bit rate result due to the MIMO transmitter and receiver sections. Then we satisfy the bit rate calculation to not maximum vary the transmitter and receiver section and to apply the bit rate for transmitter and receiver. Then to convert the VHDL code using the synthesis generator and to convert the VHDL code, then go to the Xilinx process and to simulate the overall results and to calculate the synthesis report for MIMO FDM transceiver designs using the 5G based data bit process. Next we see the final output for the product. This is our MIMO Simulink design for overall MIMO process. These are the Simulink designs to apply the two type of input sine wave formation for 5G level frequency level. Then to apply the MIMO transmitter sections. These transmission sections already we see the flow diagram for the product. Then calculate the flow process for our Xilinx based designs. These Xilinx based designs full and full used for digital based works to apply the overall MIMO signal based on logic. So we use the gate in gate out functions for transmit the ADC convert for ADC to ADC and DAC functions and to apply the AWGN channel to convert the ADC signal, then to simulate the real and imaginary times to apply the MIMO parser and MIMO signal mapper, then to convert the FFT process and to passing the IFT process to receive the receiver section for inversing the transmitter blocks designs and to convert the VHDL code using the system generator process. This generator process to convert the VHDL coding designs for our overall architecture results. Then we open the MIMO sub2 Xilinx ISC project designs. This project mainly used to system generator VHDL code conversion results to create the MIMO sub2 ISC project. This project was developed in VHDL language. So the conversion process to convert the VHDL code then to select the process and to implementation process to calculate the view RTL schematic. This RTL schematic mainly to represent the diagrammatic representation for what are the logical blocks applied to our overall design for architecture. This is the technology diagram. This technology diagram to add and create the schematic. The technology diagram to represent the buffer and lookup table and area efficiency utilization for overall architecture results. Then calculate the design summary process. The design summary process, the synthesis report to report the device utilization results for MIMO FDM transceiver designs and to calculate the timing summary results for MIMO FDM transceiver. This is our minimum period time and speed, then the latency time and the delay level for our overall MIMO FDM transceiver designs. Then to calculate the slices and lookup table functions, then the flip-flop pair and the bounded input-output results for device for overall area for MIMO FDM transceiver designs. This is our the circuit complexity reduced for MIMO FDM transceiver designs methodology. This is our overall implementation synthesis results for MIMO FDM transceiver design based on Simulink based process.